What's up, everybody? Mr. Murray here, Mr. Murray's Mathland, and today we're taking a look at geometric sequences, but specifically trying to write the explicit formula for the nth term when you're given two terms, neither of which is the first one. Because you probably know if you're watching this video that generally in textbooks and in class we would say that the nth term, a sub n, is always going to be a sub 1, the first term, times r, that common ratio, whatever it might be for that geometric sequence, raised to the n minus 1. So that's kind of the format you're shooting for to come up with this. Is you need the first term and you need what r is. And when you have those two things, you're basically done, but finding them sometimes is tricky. So, I like to say, let's think about it. There's a couple ways to do this, and as long as you use good math, you'll get there. But if I've given you, say, the fourth term and the seventh term, think about in any geometric sequence. You have the first term, second term, third term, the fourth term, fifth term, sixth term, seventh term. Just think about in a geometric sequence. That means you're multiplying by some common r value every time. You'd have to multiply by r 1, 2, 3 times to get to the seventh term. And that's in any geometric sequence, right? So I think a nice place to start here is that the seventh term will be the fourth term, whatever the fourth term is, multiplied by that mystery r value, that common ratio, to the third power, right? Because if you're multiplying by r times r times r, that's just r cubed, really. And so, that would be, like I said, in any geometric sequence, if you're going from the fourth term to the seventh term, and we're just taking the difference between these, and that's your exponent. So if this had been the 20th term, then this power would be the 16th power, for example. Okay, so now let's actually use the numbers that are particular to this problem here, which is that the seventh term is 31,250, and the fourth term is 2,000, and times r to the third. And now you can solve for r by dividing by 2,000 and taking the cube root. So if you divide by 2,000, again, I'm trying to use my calculator as little as possible. I mean, you could divide by 10, cancel those zeros, and then you're doing 3,125 divided by 200, and 25 goes into both of those. You might be able to reason it out from there that r cubed would be 200 divided by 25 is 8, and 25 goes into that 125 times. If not, if you have access to a calculator, just nice to also know these little kinds of nice tricks with your calculator. And all scientifics and graphing have something to this effect, that if you're doing 3,000 or 31,250 and I'm dividing by 2,000, I get a decimal, and most calculators have an ability to change that into a fraction in reduced form, because you don't want to round off. And again, I'm trying to use my calculator as little as possible, but I like to see this one in fraction form, because now to solve for it, I'm taking the cube root. And to me, it's a lot easier to take the cube root of this fraction than it is to think about taking the cube root of a decimal. And as you'll know, the numerator and denominator are both perfect cubes. The cube root of 125 is 5, and the cube root of 8 is 2. So there's your r value is 5 halves. And if you know r, now it's just a matter of finding, well, what's a1? Those were the two things you needed, right? To kind of finish this off. I need the first term and I need r. So I'm going to go back to this format and say, now I know a sub n will be that mystery a1 times r, which is now I know is 5 halves to the n minus 1. And I'm going to take either one of my two terms they gave me, whatever one seems maybe easier to work with. maybe I'll take this, the fourth term is 2000, and I'm going to substitute in. So again, to work with that means that it works out to be 2000 when you substitute 4 in for n, right? That's the way that works. And so a sub 1 times 5 halves to the, when you substitute 4 in for n, 4 minus 1 is 3, which again should make sense that you're really just kind of saying to get from the first term to the fourth term, it's multiplying by r 3 times. Again, that's just the difference of 3 to get from the first to the fourth. And so now let's just solve for a1. So 2000 is equal to the first term times 5 cubed is, well, it kind of looks familiar, 125 over 2 cubed, which is 8. So to solve for a1, multiply by 8/25, right? That reciprocal, 8 over 125, I should say, times 2000. And again, if you're trying to work without a calculator, you might divide 25 out a few times, or divide 5 out. But if you're using your calculator, let's see, 25 goes into there. Actually, 125 goes into there. 16. So we should get 8 times 16, which is 128. Well, let's double check here. Even math teachers make mistakes here. So 8 over 125 times 2000, and we get 128. Okay, nice to know. I'm still okay here, still sharp as I'm getting older. So a1, the first term is 128. I already knew r, so here's my final answer. A sub n will be 128 times that r value of 5 halves to the n minus 1. Okay, and so that's the way I like to do those, but it all starts with that realization that whatever two terms they've given you, you're multiplying by r to that difference in term number. So that's the way I go about it, but just to give you a different start here, if that doesn't seem natural to you, I don't think that's the way the textbook shows you to do it. So I'm just going to take this chunk out, and I'll just say, suppose you know the formula, though, you're working with that basic formula of a sub n is a sub 1 times r to the n minus 1, and you want to work with that. Okay, so if I have a sub 4 is 2000, that means when I substitute in 4, I'm going to get 2000. So if I set this equal to 2000, and that is equal to a sub 1, which let's pretend you don't know it, times r, and let's also pretend you don't know that yet, to the n minus 1. And n is 4, so 4 minus 1 is 3. Okay, so what you have here is two variables that are unknown, a1 and r. But you have a second point to use, so you can make a system of equations out of it. So a sub 7 is 31,250. And you go back to your original format, you plug that in, so you're setting it equal to 31,250. That will be that same first term times that same r value, but in this case, when you plug in 7 for n, you get 6 as that exponent, right? Okay, so now you have two equations with the same two variables, and it's just using algebra, little system of equations here. So one thing you might do is take either one of them and solve for a sub 1. So if I take this first one here, and I'll just solve for a sub 1, that would be 2000 divided by r cubed is equal to the first term. And then I'm going to take that and just system of equations, I'm going to use a little substitution. I'm going to replace a sub 1 with that expression. So I have 31,250 equals, and when I put 2000 over r cubed, and that's times that same r to the 6, you see what you end up getting is that r cubed goes into r to the 6. You're left with 3, and so you're right back where we were a minute ago, that 31,250 equals 2000 times r to the third. And then you're doing exactly what we did after that. You divide by 2000, you get r is 5 halves, and then you're plugging back into that to solve for a sub 1. So if that first step of just kind of starting here didn't feel natural to you, then just go back to the original format and set up a quick little system of equations. Solve for a sub 1 and substitute into the second equation. And there you go. Hopefully this makes sense. If you have any questions, let me know.